So let's excuse me. Let's look at some gear system problems here. Um, let's say for our first one, I'll just do two examples here. For number one, we uh, we have a motor that can output, let's just say, 5 foot-pounds of torque. So um, input is 5 foot-pounds of torque. So we'll do five. Actually, let's do Newton meters. Just Newton meter. Oh wait, it's Nm, right? Not over M. And 5 Newton meters of torque. Um, and let's say that. So that's what our motor can do, and we want. Let's say we want to lift uh, a 20. Let's just say that our objective torque is 20 Newton meters. So this is our motor, and we want 20 Newton meters. Okay, so um, in this case, right? In this case, we're going to have a small gear as our input. I'm not going to draw the teeth. And we're going to have a big gear as the output. So what that means is as this turns, right, turns kind of quickly, it's going to slowly, wait, sorry, make sure I have the right rotation direction here. It's going to slowly start moving this guy. And so it takes more turns to rotate this. So it's going to be slower, but you're also going to incrementally be moving whatever your load is much slower than if you were to be using this. And so that's kind of how the whole torque thing works with these gear systems. So, right, our, how do I want to write this here? Our output torque that is desired is 20 Newton meters. And so for our gear system, it equals our input torque times the number of output teeth over the number of input teeth. So our input torque is 5. And then we just have a ratio here, right? This is a ratio. We have two unknowns. And so actually what I'm going to do here is I'm just going to do R. I'm just going to put an R here. And so this is pretty easy to solve for R, right? R equals 4. So that means for every input tooth, I have to have 4 output teeth. So that means there's actually, this is a ratio that I have to have. It's 4/1, right? 4. But that means there's an infinite number of solutions we could have here. You know, let's just say that our input has 10 teeth. So that means our output needs basically our input times 4, which is 40 teeth. So that's how that works there. Let's look at another case where our motor can go. Let's say so. Input is let's say 20 RPM. And let's say that we want our output speed to be 100 RPM. So in this case, right, for speed, the way our speed works is our output speed, so we want 100, equals the input speed of 20 times the input teeth over the output teeth. So this is just another r here. So we'll solve that. And so, right, r equals 5. So the key thing here is to make sure that you've if you're working with speed or input, you need to know which formula you should be using, right? So if it's torque, remember it's the output torque equals input torque times output teeth over input teeth, where the output speed is input speed times number of input teeth over output teeth. So just the ratio is flipped here. So that means that, say we've got, in this case, if we had an input of, let's say, 100 teeth, our input is 100 teeth, then our output would have to be 100 divided by 5, right? 100 divided by 5, that's 20. So that's kind of goofy there because I just used the numbers of the speeds, but either way, it still works there. So so in this case, we've got something like, we've got something like this. That's right. This is our input and output. So you can imagine that as this makes one revolution, this is going to make multiple revolutions, and that's how we can kind of get that multiplication effect to happen there with the speed. So that said, this also has a downfall in that we're increasing the torque, but we're going to be decreasing the speed. Here we're decreasing or increasing the speed, but decreasing the torque.